In today's video, we are going to explore the concept of flame emission spectroscopy, which is also sometimes known as flame photometry. This analytical technique is based on a similar principle to the more basic flame test that you may have seen before. The underlying idea is that when metal ions are heated to high temperatures, they emit light as a result of the excitation and subsequent relaxation of electrons, the wavelengths of light that are emitted, which determine the color you can see with your eyes, are specific to the particular type of metal ion that is being heated. This characteristic emission makes it possible to identify metal ions by observing the light they give off. In a basic flame test, we simply introduce the metal sample into a Bunsen burner flame and observe the resulting flame color. This can be a useful quick test, but it has significant limitations, particularly when two or more metal ions produce similar colors or when a sample contains a mixture of different metals. In these cases, it becomes difficult to interpret the results accurately because the colors blend together and become ambiguous. Flame emission spectroscopy solves these issues by using a scientific device called a spectroscope. The spectroscope is capable of detecting the specific wavelengths of light emitted by the ions rather than just the overall flame color. Every different metal ion produces its own unique pattern of emitted wavelengths, and this is shown as a unique line spectrum. This line spectrum serves as a fingerprint for that particular ion, making it possible to accurately identify what metal ions are present in a sample. Furthermore, one of the advantages of using spectroscopy rather than just observing colors is that the intensity or brightness of the lines on the spectrum provides information about the concentration of the ions in the sample. So flame emission spectroscopy can be used not just to identify which ions are present, but also to determine how much of each ion is there. This makes it a very useful tool in both scientific research and industrial applications. Another very helpful feature of flame emission spectroscopy is its ability to handle mixtures. When a sample contains multiple different metal ions, the resulting spectrum will show the individual emission lines for all of those ions. For example, if we had a sample that contained metal ion A, which produces a certain pattern of spectral lines, and metal ion B with a different pattern of lines, then the spectrum of the mixture would simply include all the lines from both A and B combined. This can look confusing at first, but by comparing this unknown spectrum to known reference, spectra scientists, or in many cases computer programs, can figure out exactly which metal ions are present in the unknown sample and also determine their concentrations. If you are asked a question about this in your exams, the best strategy is to compare the spectral lines of the unknown to those of known ions and match them to determine which ions are present. For instance, if two of the known metal ions have line spectra that perfectly match the lines in the unknown sample, then those are the ions contained in the mixture. This analytical method also provides an excellent example of the differences between traditional manual testing methods and more modern instrumental techniques. While manual flame tests are easy to do and very cost-effective, they are not always reliable, especially for mixtures or closely colored ions. In contrast, instrumental techniques like flame emission spectroscopy involve more complex and expensive equipment, but they offer superior benefits in terms of performance. Specifically, instrumental methods are known for their high accuracy, meaning they give correct and reliable results, their high sensitivity, which allows them to detect even tiny trace amounts of a substance, and their high speed, because the processes can be automated so they do not require constant human effort or attention. These advantages make instrumental methods essential in laboratories and industries where precision and efficiency are crucial. Anyway, that brings us to the end of this video. We hope all the ideas made sense, and we will see you again in the next one.